We're continuing with section 14.8, Lagrange multipliers, and still two variables. Example 2, find the extreme of function f of x and y equal to x squared minus 4xy plus y squared, subject to constraint g of x and y to be equal to x squared plus y squared equal to 1. If you remember, this is the same function as the example in section 14.7, and in 14.7 we were finding inside the disk. Here is just on the boundary of the disk. So how do we go about this? First, you find a gradient of f, which is 2x minus 4y and minus 4x plus 2y squared, 2y. And then you find gradient of g, that is 2x and 2y. Then you said gradient of f equal to lambda gradient of g. That is two equations, 2x minus 4y equal to lambda times 2x, and negative 4x plus 2y equal to lambda times 2y. We need a third equation. The third equation is going to be x squared plus y squared equal to 1. If you solve for lambda in the top and bottom, you get lambda equal to x minus 2y divided by x, and the second one, lambda equal to minus 2x plus y divided by y. Set the two equal to each other, and solve. So one thing to consider before continuing further, you're assuming here that x and y are not equal to 0. So there is a possibility that actually x and y equal to 0, they satisfy, that point satisfies the first two equations. So you have to be considerate of that. But what you notice is that if you plug in 0 and 0 in the third equation, it's not going to satisfy the third equation. So x and y equal to 0 does not work. So now it's time to just solve this without worrying about x and y both being 0. And so that's the solving that gives you xy minus 2y squared equal to negative 2x squared plus xy. Xy from both sides simplifies, and you get x squared equal to y squared. And from there you get x is equal to plus minus y. Again, this division was possible because we knew even though x and y equal to 0 satisfy the first two equations, it didn't satisfy the last one. And this was when we were doing this problem in 12.7. The origin was part of the problem. Here we're just working on the boundary. So you found x and y equal x equal to plus minus y. Plug it back into the third equation down up here, and you get x squared plus 2x squared plus x squared equal to 1. So x squared plus x squared equal to 1, that is 2x squared equal to 1, and that means that x is equal to plus minus 1 over square root of 2, or plus minus square root of 2 over 2, if you rationalize it. And then, so y is going to be plus minus square root of 2 over 2. This gives us 4 points. Point square root of 2 over 2 and square root of 2 over 2. Point negative square root of 2 over 2 and negative square root of 2 over 2. Point square root of 2 over 2 and negative square root of 2 over 2. And point negative square root of 2 over 2 and square root of 2 over 2. Checking all the values of f on the values of f on each of these points, you can find which one is the absolute maximum, which one is the absolute minimum. So here it's done in this table. In this table, you see that the two of the points, if evaluated in the function, are going to give you -1. The other two give you 3, and those are the maximum. These are the minimum. So this is another method of solving for the boundary of the optimization over a boundary of a region, basically. So that's the that can be seen in here. Now let's do iClicker 14.8b. Suppose that x and y are positive numbers such that x plus 3y equal to 12. What is the maximum value of x times y? And give yourself a minute and we come back. So g of x is x plus 3y, f of x equal to x times y. Lambda g is 1 and 3. Lambda x f, sorry, gradient of g is 1 and 3. Gradient of f is y and x. Now, gradient of f equal to lambda gradient of g gives you y is equal to lambda and x is equal to 3 lambda. Here you, and then the third equation is going to be x plus 3y equal to 12. Solve by eliminating lambda, and x over 3 is equal to y. Replace over here and you get 2x equal to 12. That gives you x is equal to 6 and y is equal to 2. Now, so the next question is whether or not this gives us the maximum. We're trying to find the maximum of x times y. It's important to look at the constraint. Constraint is x plus 3y. So x plus 3y equal to 12. Here's the 12. Here's 4. And this line is the constraint. It is not bounded, but you can tell that over the bounded set over here is the only time that it's x times y is going to be positive. For the rest of the line, it's going to be negative. And we establish so over the bounded set at the endpoints, the value of x times y is going to be 0. So actually, x times y equal to 12 is the maximum. of b